is a discussion around the test approach and lessons learned in a microservices project. So the customer that we were dealing with, hold on. Does that look okay? I've got a really, it looks really strange on my end, sorry. I don't seem to be able to see all my slides. Apologies for my IT issues. Can you see that okay? I'm really sorry about this.
Yeah, we can see your screen, Steve.
Can you see the slides okay?
Yeah, it looks like you're in like edit mode, but yeah, I can see.
Okay, switch to play. Okay, right. I think I know what's happened. Yeah. Okay, so the background here is it's a UK brand. They're doing a comprehensive digital evolution of an e-commerce platform to turn it into a world-class customer interaction hub. And we've been, we as a test consultancy, we've been contracted out to do some work on helping them with the testing of it. So the main goal is to re-platform the whole site. The idea is to take an approach where they're going to do a side-by-side build of the existing software and replicate that as a microservices backend with a React.js front end and implement a headless content management system. The existing platform was really old. It was based on React 9. There was a lot of legacy components there, and it really wasn't fit for purpose. So some of the testing challenges around that were that there was a small test community inside the existing organization, minimal test documentation about how the existing solution used to work, a general reluctance to change inside the organization. There were several problems around shared test environments and data issues inside the organization, and process in general was just poorly defined. So, for example, there were no test strategies, there was no real approach to automation, and a general mistrust of test automation. A lot of the testing was done by SMEs who had a lot of deep knowledge of the existing solution, but had no real technical capability. It all come from sort of like a call center type background. So it's very difficult for the organization to modernize and move on. So the solution was, as mentioned initially, it was replacing this monolith. The idea was to decompose the monolith into a series of backend components, all built in microservices, hosted in Azure. So there were 10, I think there's 10 microservices in total. For the purpose of this presentation, I'm just going to talk about a few of them and the test approach around that. So there's a pricing service which allows which was a REST-based system. They're all REST-based microservices. The pricing service allows customers to select components of the products that the company sells, and then based on the selection of products, it will come up with a unique price. An order processing system which maintains state, is backed by a database and stores all the cached orders, as part of a workflow before people actually move to the checkout process and actually buy the products and services. A content API, which obviously, as you can probably imagine, just hooks into the CMS and provides all the content that comes back from the back-end CMS product. And then just as an example, one of many integrations with other third-party SaaS solutions, a postcode and address lookup service. So one of the key learnings straight away there for us as a team was to develop an approach. It was important for us to go in early, define a test approach, especially where there was a lack of organizational best practices. So we came in to suggest and adopt the adaptation of best practices, gain buy-in with all the key players. We were brought in as a test consultancy to work with a development partner and then other third parties within inside the organization. So it was important to make those relationships and really talk to everyone inside their organization, make sure that we were building that consensus and getting the buy-in, that the approaches we were taking, were the right things to do. We were not running before we could walk. Take people along on the journey. And generate some documentation. We didn't want to go in and write War and Peace from a test strategy perspective. I just wanted to generate some lean documentation. So the mantra as much as necessary, but as little as possible. And then importantly, keep that document updated. Bad doc is worse than no doc. We defined it inside the organization. There were examples of that where we would be looking around as a team to find some reference material, but it was actually out of date and was no longer relevant, which actually caused us more problems than if there was no documentation in existence. We were starting from a false starting position. So really, really frustrating. So as part of our definition of how we're going to approach this project, we defined a plans of how we're going to handle test execution. So obviously we want unit tests. That's obviously handled by the development team. The unit tests, the unit test coverage, was targeted as 80%. I think that's a really good value. Obviously, as testers, we can support the development team with unit testing, but that's not obviously our key focus. The back-end component test, initially we want to execute some component level tests on the built service as part of the development pipeline. So the idea was we were going to work with the DevOps team to build that as part of the workflow. So just some very simple checks with basically mocks and stubs wrapped around those kind of components. We want to build back-end integration tests, run both scheduled and on demand in the development and test environment. So once the containerized applications have been built and deployed, we wanted to then run the entire suite of tests against those integrated components. So as I mentioned before, there's a number of microservices based components. So it was possible to run lots of individual tests against those when they're fully assembled, in a good set of integration tests. Equally, once the project had got to a bit closer to fruition and the front end components were developed, we then wanted to switch focus and also start writing some front end component tests of individual components, and there are a lot of frameworks that allow you to do that, especially around React components. And then also, to sort of really close off everything else is to write some end-to-end tests, and again have those built into a CI pipeline and run those both scheduled and on-demand in test environments. So a key learning here for us was around developing the approach is that I seem to have gone backwards. Apologies. Sorry. So an example of how we wanted the test execution to look in Azure DevOps. We wanted to have the pipelines inside their DevOps platform. A really clear dashboard of where those things live. Clear naming conventions on what the jobs actually do. And then obviously, as you can see, an example here of some of those tests that have been run. With obviously useful commit messages to tell you what had changed and why the test run, and then as you can see, an indication that some of those tests have passed, and one of those there's been potential failure. Another key learning is we wanted to make sure that we had good visible test reports. So here, this is just the reporting framework that comes built into Azure. We did initially look at using a law reporting, but it really didn't give us much above and beyond what you get out of Azure DevOps. So there's no point in unnecessarily importing lots of extra libraries, that provide, little or no additional functionality over and above the platform that you're already using. Okay, it seems to be one sec. And another key thing we wanted to implement is that we wanted to alert people. So rather than just have those messages published onto a dashboard, we also wanted to make sure that the wider team saw those as quickly as possible. Not everyone's aware that tests are running all the time and that there's dashboards. So we integrated with their messaging platform. And this is just an example of using a webhook to send a message into Microsoft Teams to let everyone know the current status of a set of tests. So as you can see in this example, some of the tests did pass, 7 failed. It provides a little bit of feedback as well as a link to take whoever's looking at our message to the test results, so they can then start to diagnose and triage the problems. Key learning here was, though, to get some DevOps supports. It's so important to ask the experts. We tried to reuse pipeline configurations where possible. We followed good naming standards. We leaned heavily on the DevOps team, so we had to create tasks for larger pieces of work and get those added to the backlog, and then get the DevOps team to support us as and when it was possible. And we also had to adapt our approach. There was a general lack of DevOps resource. While we did get some of those things built, it was very difficult to get our work scheduled in, as you can imagine. And there's also an actual live development project going on, so they can't always focus on just the test side of things. So we had to be adaptable with our test approach. Our initial component test approach was replaced by greater test integration coverage. So it wasn't actually possible for us to take the component testing any further than through the experimental phase, just because of a sheer lack of DevOps support. However, because we had really good levels of coverage across the component, across the integration tests, it wasn't a problem. It didn't impact the quality or the success of the project by not having those individual component tests. So just to drill into some detail around the actual test approach. So from the Postcode Lookup service, this was a relatively straightforward set of tests. There were 36 test cases in total. It was just a pass-through API to a third-party software as a service solution. So we had a series of both positive and negative tests. That was quite key. And it was just simple tests on postcode and address search. So sending partial addresses in, seeing what the response comes back, sending in specific postcodes, making sure that those responses are correct. From a content service perspective, this was a relatively straightforward API to test. It was just fronting the CMS system. So it was just the tests were mainly just a series of simple GET requests just to retrieve specific bits of CMS content, just so that we could validate that the basic functionality of that wrapper API was working correctly. It was relatively straightforward. All these tests were written in C# using REST library, and we took an approach to not use BDD. There was no test cases specified in BDD, so no need to use a BDD test framework. We didn't need that extra overhead. And then for the orders database, this was again relatively straightforward. A few more operations here. It wasn't just GET requests, but again, it was just an API fronting a data store. It wasn't possible for us to gain direct access to the database that this service was wrapping around. So we just had to do everything through basic CRUD operations. So create, retrieve, update, and delete, which obviously maps onto the HTTP verbs, get, post, put, patch, and delete. So again, a relatively straightforward set of tests to just wrap around all that functionality and make sure we're testing the right amount of functionality that all the other services would ultimately integrate with and use. However, the pricing system was the more complex of all the microservices that were built. It was a very complicated system on the inside. So in general, the organization was running on a legacy system. They had a very complex pricing system built in an old VB application. The pricing algorithm was then partially implemented into Excel as the mathematical model mapped into Excel. But there were known problems with that Excel solution. Any price changes that were distributed throughout the company were sent to the testers in a spreadsheet. So basically, the mathematical model was used to create the new price points and differentials. And then those things were sent out as an Excel spreadsheet for the manual testers to then verify that the system with the new pricing algorithm built into it was actually producing the relevant prices. As I said, this was because the Excel spreadsheet was known to be inaccurate for certain edge conditions. There were known to be some problems, and the prices vary based on source and promotion code. This is just some internal naming convention that our client, the company, use. It was just a way of them varying the prices based on their affiliates and the channels that they sell their products through. So it was very important for us to make sure that any pricing data that we were using from a test perspective was machine readable. The spreadsheets that were distributed to the testers were very complex spreadsheets. It wasn't just it wasn't like multiple lines of CSV. It was a very complicated spreadsheet with multiple sections and tables scattered around. So that wasn't easily machine readable. So the approach we took was to get the core pricing data table, as well as all the optional services added in line, into a single file, which was the majority of our pricing test data, and then have additional fees in a separate file, which was then machine read at the same time as we executed our pricing test. So as you can probably imagine, I've hinted at this. The way the pricing system in this particular customer, this particular e-commerce platform works is very, very complicated. So there's a lot of data that goes into the underlying calculations, so that when customers place products in baskets, there is a lot of different factors in play and a lot of test cases for us to cover. So the way we approached the verification of this, it was quite complicated. There was a very large JSON response that comes back from any pricing request, because of the response contains additional options that are listed as differentials. So basically, the response returns some information that the front end can then use to suggest the price jumps for additional items that people may or may want to add into their shopping basket before they actually check out and buy the services and products. There are multiple options and related assertions required for that because there's just a very large number of possibilities, and that obviously increases all the test items. And this just highlighted how difficult it was for the organisation to cover this. The sheer number of combinations means it was not possible to reasonably cover all those test cases manually in any sensible time frame. So it was clear at this point to the development team and also to the existing people within the business that test automation here was critical, and obviously you don't want to make mistakes with pricing, especially if those prices are live. There's a possibility to cause some real harm to the business if there is incorrect pricing, available on a live website. So it just highlights the importance of, focusing on test automation for this particular service. So the key learnings here for us were that it was so important to build relationships across the wider team. We had to interface with a completely separate part of the business that handled all the pricing. That was part of their bricks and mortar type business. So it affected not just the digital side of the business, but also the bricks and mortar side of the business. They had a lot of domain knowledge. It was really important for us to gain that domain knowledge just so we were asking the right questions and building test cases in the right way. We needed to get the data in a usable format. That in itself was a business challenge because they weren't used to producing it in that particular format. That was something we had to overcome. To actually then build the test, we took a data-driven approach to this. So again, it was a C# based test using REST Sharp, but ingesting the various CSV files and then iterating through all the possible combinations in nested loops, executing multiple calls. Each call would then produce a test response back. And then we just assert on the relevant values. Each call was relatively quick, about 100 milliseconds, but due to the sheer number of combinations, a modest file of about 116 lines of CSV would would result in 900 test cases. Just because of the nested loops that were applied to all those various combinations, and then the various other iterations that had to go through from the additional fees and the additional data in the tests. So a very complex set of tests derived from a very small set of data, which would then scale up as more and more prices and affiliate channels were added to the e-com platform. That would just scale out and just get a bigger and bigger and bigger, but obviously be relatively easy to manage because we were just driving everything from a data-driven set of tests. And then on to the front-end test approach. So at the point where we'd completed all the back-end testing and the back-end team had also built their, built and closed out all the API services, the focus then moved on to building the front end. So the approach here was to have a rebuild of the existing components to retain the existing look and feel. Because this was a side-by-side re-implementation, the business felt that they didn't want to include any massive amounts of change. They wanted to keep it looking exactly the same as the last one to be sure that any problems or failures once the swap over had taken place were non-technical. Were technical. What they didn't want to do is change the look and feel radically. And have that affect the conversion rate in any way. So the idea was to just build it exactly how it looked initially and then start to innovate afterwards. This was React.js based, so very much a JavaScript developer skill set. So key learning here was we had to work with a slightly different development team. Their focus was on JavaScript. So we initially looked around for some tooling, working with the development team. The decision was made to go down the route of using SIGiST for both the component and end-to-end tests. Obviously, this is easier to support JavaScript-based test tooling because that's where the developer skill set lies. The approach we took was to have key journeys tested with minimal pricing tests. Because we'd already built a large amount of integration tests at the back end, we were able to rely on that, to do the heavyweight testing of all of that functionality. So what we didn't want to do is end up with multiple journeys through the front end product and then have to test and assert on every price and combination, because you can probably imagine that multiplies out into a lot of possibilities, even for a very modest shopping basket full of potential flows. So what we want to do is make sure that we were only testing the key bits of the UI and just testing the pricing at the lower levels. The focus was on using the Chrome browser initially. This was calculated based on metrics that this was by far and away the most popular browser, and then ultimately we would move to a cloud-based provider for multiple platforms and devices based on the metrics available, from the internal organization. They were able to provide us with some Google Analytics that told us which platforms and devices were the most popular, and we target the testing appropriately. And we were also going to use Google Lighthouse for some non-functional testing, just to make sure that the web page and the workflow through remain responsive. Another key learning here was focusing on the test pyramid. I think it's quite easy sometimes for people to get hung up on the test pyramid. It works better literally rather than figuratively. I think if people try and obsess over the various test layers, it's unhelpful. In our example, we were able to perform or build component level tests at the lowest level of the software stack. But because we had good integration tests, we would effectively have ended up with a test hourglass. Because we weren't able to do that, we still had good test coverage. So I think it's just an important lesson there, that you don't have to worry about testing at the lower levels. If it's not possible to do it, be adaptive. I think that's the key, as with anything in software testing. So to sort of wrap this up, our overall test automation implementation, we now have, for this organization, we have automated tests able to run on a commit. That's a very lightweight set of tests that only takes a few seconds. There's a slightly larger set of tests that run when a merge happens. As you can appreciate, there's a bigger amount of change there. So we're going to make sure that we've got a lot of test coverage on proportionally higher set of test coverage on mergers. On deploy, we run the full suite of tests, both back end and front end, and it's also possible to run those tests on demand on any test environment, as and when things change. And there are frequent scheduled tests as well, just running as general health checks, just to make sure that all the test environments are fit and healthy. So a summary of the takeaways there. It's important to agree on an approach as soon as possible. So work with as many people as you can within the organization, make sure that there's broad agreement and buy-in, because especially if you're coming into an organization from the outside, you want to make sure that you're working with people and not having to fight them. It's also important to get the support you need and escalate if necessary. It's also key to be very adaptive. Best practice isn't always best fit. In an example of changing the test approach, it's very important to sort of like take a pragmatic approach. What the book says isn't always the right way to do it. So just be aware, adaptable is good. Keep tech choices simple where possible. We had a heterogeneous tech stack. The back-end tests were all in C#, which makes sense because the developers work in C#. That doesn't mean you need to go down the C# Selenium route for front-end testing. It's okay to have a completely different set of testing tech. It's down to the maintainability of that. If it sits with the skill set of the testers and the developers, then that's fine. You should never enforce a specific set of tooling and try and have one set of tests that does everything. It's also important to make sure that your tests run frequently and surface those test results. Make that stuff as visible as possible so that everyone can see everything that's happening. And then once you've got that buy-in and that visibility and awareness, then have people who are looking out for test failures, going into the dashboard when failures happen, triage the results, raise defects. It shouldn't be false positives, but if it is a false positive, obviously find it and fix it. But just make sure that your test environments are running, as healthily as possible all the time. It also highlighted to us that business domain knowledge is crucial. If you don't understand the underlying business of the organization you're working in, then you will find it very difficult to write good tests and find a good test approach to how those things should be done. And use the right tool for the right job. And it doesn't necessarily have to be the tool that you originally set out to use. Have a conversation with the organization that you're working with. Make sure that the tool suits them as well as you. It needs to suit everybody. And also, as I mentioned, the skill sets. And another key takeaway is don't worship ancient relics. Certainly the test pyramid has its place, but it definitely should be treated figuratively rather than literally. Okay, has anyone got any questions? I realise I blitzed through that probably a little bit quicker than I probably would have done.
Thanks, Steve. That's great. I don't know why my video isn't appearing, but what the hell? I'm trying to make an appearance on screen. In the audience, if you can post questions on Slido, I know people wait until the very end, and then before you know it, we've got to move on to the next speaker. But if you can get any questions in Slido, it'd be really helpful to everybody concerned. I'm kind of interested in how the testing strategy, not the strategy, but the tests applied throughout the various stages evolve over time. So, you know, when code's available, you can component test it. When you've got an integratable piece of software, you could perhaps build some integration tests, and all the way up to end to end. I mean, how did that, if you like, framework of tests evolve over time? I mean, presumably through conversations with the stakeholders.
Yes, absolutely. So it was down to how the piece of software evolved. So we effectively tested it from the bottom up, from the smallest components being assembled up into the actual full solution. So yeah, initially it was to use the example of the Postcode API and perhaps the content thing, just a very small set of microservices, which were then integrated into a bigger solution. So yeah, the test started off as a very small health checks. And then as more and more functionality was implemented, we had to go back and re-implement extra sets of tests throughout. And it was all, a lot of that was driven from the work just coming through the boards, but also we needed to make sure that we had good test coverage of the overall solution. It was a very good example of agile development where there was a very loose set of requirements as such, and the product just evolved over time. The ultimate goal was to produce a like-for-like representation of the existing Monolith solution. So yeah, there was a constant evolution in the testing, and it was through good communication that when the developers implemented new features, the test team, our testers were informed, and then we built those extra tests. Sorry, it was all just pushing work through the boards through with it, so everything was. We made sure everything was tested and picked up. Yeah.
Cool. Okay, I've got a question on Slido. Anonymous, I'm afraid. Thanks for the talk. And the question is, who brackets which roles in the operational space looked after test suite management? I guess that's talking about, do the users get involved in maintaining tests at all, or was it all done by you guys?
So initially it was done by us. We were brought in as a test consultancy to work on just the testing side of things, when working in parallel with a development organization that had no internal test expertise or experience. And that was through the early phases of the project, we really led the way from a testing perspective. At the closeout of our part of the work, when the site had gone live, we handed over our test assets and the responsibility of maintaining all that to some internal testers that have been hired by the organization.
Okay, and that worked okay. There was a good handover. Sometimes
yes, there was a good handover period. We upskilled them all. They had obviously we walked them through the test implementation, and then they were able to pick that up and use it themselves.
Yeah, super. Another question, then we'll close, Steve, because we did start late, but I've got to give you a bit of time. Question here is, as a consultancy, how did you get the, in quotes, business domain knowledge? I mean, how do you pick the brains of the people in the business?
Yeah, it's about building relationships. So I was involved in quite a lot of this. Certainly all the work around pricing, it involved myself, one of the lead testers, and the representatives of the pricing team within the business, just having conversations. So we set up a session. We explained to them what approach we were trying to take, and we thrashed around some ideas around how we could get the data format. Obviously, they were used to producing that data in a very specific format. So through a series of conversations, we had to work out an approach where we could find the bits of data that we needed and then transform that ourselves into the data which we could then use in our tests. So unfortunately, it wasn't a fully seamless process in that they just press a button and the data appears in a format we can use. We had to do some hand cranking of it, but obviously, they're now aware that we want that data in that format at some point that can be addressed, and it will smooth it out. But certainly it's a good halfway solution in that it's repeatable, it's a well-documented process to generate the test data. Also, as I said, ultimately we would want that to just be a push button exercise of when some new pricing comes out, it's just a copy and paste. But at the moment, so certainly at the time of writing, it was a manual step just to copy and paste some bits of CSV around just to format it for the purposes of our data-driven test.
I think as time goes on, people who are dealing with data get to know and love it. They get a feel for how it works as well. And I think through that, you also learn a bit more about the business as well.
Yeah.
I have to kind of close it there, I'm afraid, because we have our breaks to get through. So, Steve, thanks once more. And to the audience, we'll restart in about 7 minutes at 10:35. Okay, so please be prompt if you're going to come and join us or not leave at all. So thanks, Steve, once more, and we'll close it down there, and we'll be back in 7 minutes at 10:35. Thanks very much indeed.
Okay, thank you all. Sorry for the IT issues.
Yep, cheers, Steve. Take care, mate.
Bye.